Hi, my name is Gavin Raykemper, and today I'm going to tell you about how we built the Application Index Coronavirus web app. Application Index is a web application that showcases dashboards and apps that states, counties, and cities have created. It organizes them by geography and embeds them in the page with a tabbed interface at the top. The goal is to allow citizens to find COVID-related information that applies to their particular area and quickly and easily. You can see the application live if you go to coronavirus-resources.esri.com and click Index of USA applications related to COVID-19. When a user arrives, the national resources are featured on the tabs across the top. Currently there are 4. These resources are dashboards and apps that other organizations like states, counties, and cities have created. They are compiled using ArcGIS Online items and categories, which is what this application reads from via the ArcGIS REST API to display the resources. The resources are organized at geography levels, so if the user clicks Arizona, for example, the map updates, the states list changes to counties for Arizona, and now the Arizona state apps are shown in the top bar. The user can then drill down into their county if that's available, and it would show county resources. An important thing to note here is that since we are embedding the dashboards and apps that other organizations are creating, there is a chance that they may not display properly. Because of this, we display the full URL of the application at the bottom, with links to copy the URL to the clipboard or open the URL in a new tab. As I mentioned earlier, the data for this app is managed in ArcGIS Online via items and categories. So we use the ArcGIS REST.js JavaScript library to assist with accessing the data in ArcGIS Online via the REST APIs. We use the ArcGIS API for JavaScript loaded via Esri Loader to display and update the map in the bottom left corner. Overall, the application is using React.js front-end library JavaScript framework, and it was created using the Create React app bootstrapper. To aid in display and layout of the page, we use React Split JavaScript library and Node Sass for styling. I'll now go through each of these a bit more in detail. When the app initially loads, it must query the ArcGIS REST APIs to get items and categories for the ArcGIS Online group where we are storing the information so it can build the full UI of apps, states, counties, etc. It's a lot of data to query. Here's one example of a function where we're getting the group category schema. The portal URL and group ID is passed in, and the ArcGIS REST request library is used to make a request to the category schema endpoint, passing the format as JSON parameter. When the result comes back, we resolve the promise with the resultant category schema JSON object, which is then used in the parent function that originally called our function. We're also using other ArcGIS REST.js functions in different ways too. Check it out if you need to access your ArcGIS Online or ArcGIS Enterprise REST API. You can visually see the overall structure of the application. There's a sidebar on the left when listing the states and a map. On the right is the tabbed interface with the application embedded. We want the sidebar to be resizable by the user. To quickly add that functionality, we use the React Split library. Here's a sample of some of the JSX code at the top level of our application that puts everything onto the page. The first item is the React Split tag, passing in the original sizing, 25% and 75%, and some other settings. Then we include a modal component, which is how the modal that pops up when the page initially loads gets called. Then is the sidebar component. A lot of properties get passed into this component as it needs a lot of data and events so that it can build the UI. Finally, we have a main area component that contains the tabbed UI and the iframe to embed the apps. The ArcGIS API for JavaScript powers the map in the sidebar. It initially loads the state boundaries layer from the calculated labels for numbers of resources within each state. When a state is selected, the map is programmatically zoomed to that state, and the counties layer is displayed. Here's a sample of code that creates the initial map using the load modules function of Esri Loader. It asynchronously loads the web map and map view modules, then uses them to create a map based on the web map stored in ArcGIS Online, and then creates a map view based on that map. When the map view is ready, we call a few functions to update the rest of the app based on the currently loaded map data. SAS CSS preprocessing has been around for a while, and we're using it in the project to make our CSS styles more clean and efficient. We can import it directly to our React app using the import syntax, and then those styles, an example on the right, get loaded onto the page. One of my favorite functionalities of SAS is that you can nest your styles to create hierarchies of specific CSS rules, which is nice for organization purposes. The backend data is being managed and stored in ArcGIS Online. Because of this, deployment of the application was relatively easy. All we had to do was build and export the app using the React app scripts and get them onto a web server. In this case, we deployed them to AWS S3 and used the AWS CloudFront CDN cache to ensure speedy delivery of the files to browsers across the world. This app included many different technologies like the ArcGIS REST.js, ArcGIS API for JavaScript, React, and SAS. They all came together to create a great-looking web app that helps users find resources quickly and easily, which was the original goal of the project. Thanks for joining, and good luck on your next web development project.